Hi, this is Robin Way of Corios. My colleague John Willie and I are going to share with you the story of real-time analytic scoring. This is the ability to push real-time analytic information and recommendations to customers, claims, offers, and prices via both push and pull strategies. When I talk about push and pull strategies, what I mean is first, we want to push analytically derived recommendations to the field so that people in our business who work with customers can give them better information and better recommendations to customers that serve their needs better. And second, that motivates the business to develop and deploy their analytics faster. The faster we want to help the people in the field and our customers, the faster that we also have to be able to develop and deploy those analytic models. So here's the primary use case. Imagine that you're an insurance company and you have underwriters sitting at underwriter desktops receiving calls to price new and renewing policies. Well, their desktop applications are running on top of an enterprise service bus. That means that they have an enterprise framework that they can submit requests to generate new prices on the fly. And there will be an analytic process waiting for them in the background that's going to calculate those new prices to put onto those policies. There could be 3, 15, or 500 different underwriters working in your business waiting to generate that information. And they could be submitting information to that enterprise service bus one at a time, 10 at a time, or thousands at a time. That's the purpose of having a service bus, is to be able to receive lots of requests and to push them to a decision master service. And we build our decision master services in SAS. So every second, every few milliseconds, or every couple of minutes, depending on the nature of what the enterprise wants to do, the enterprise service bus will pull decision master service to generate new scores. And when that happens, we kick off a couple of different jobs. First, we need to grab data about those customers and those policies from around the business. So we have an ETL service that's a child of the decision master that retrieves the customer IDs, and we generate a log. We pass the results of the ETL to a scoring service, which scores those customers and policies, say in this case for a new price. And we write those results to a scoring log. And we close the request, sending the information back to the decision master, which sends it back through the enterprise service bus to the underwriter's desktop. This process could take milliseconds or it could take a couple minutes, depending on the complexity of the ETL and scoring job. Usually the ETL service is the one that requires the most time. We've put this into production in several different financial services client environments, and we've learned a lot about that process. Mostly that while this is the push story, pushing information in real time back to people who interact with customers, there's also a pull strategy. And that pull strategy is we have to deploy our models faster for a couple of reasons. First, models cost time and money to build. Models also have a shelf life. Initially, when we deploy a model, it performs at a certain level of efficacy, but as the model ages and customer behaviors shift, that efficacy drops over time. And so that also costs the business money. Eventually, we start to build a second release. And most companies that we observe don't nearly get enough value out of reuse and recycling of the model assets that they produced the first time. So it costs them just as long and it takes just as long as it did for the first model. That second model goes into place and it loses its efficacy over time and the cycle continues. What we recommend is to find ways to reuse and recycle those model assets so that it costs you less time to build and deploy those models the second, third, fourth, fifth time, and so on. You also lose less efficacy when you have faster cycle times. So the value proposition for the pull strategy is we want to lose less money. That's the comparison between the light blue and the dark blue arrows. And we want that effort to cost us less. That's the difference between the large blue box and the small blue box in terms of the effort it takes to build those models. When we use the pull strategy, we're going to make more money for the business. So now let me share with you, via my colleague John Willie, 5 use cases. We're going to launch a decision master service. We're going to launch the child processes for ETL and scoring. We're going to have those processes check an ETL log and the score log to make sure that the job is running successfully and that we have a complete audit trail of all the activities for all the customers that we're working on. And then we're going to display the scores back to the screen that were generated in real time. John, take it away.
This is SOAP UI. SOAP UI is a free open source application that we will be using during this demonstration to test the web services described during the earlier presentation. These web services were developed using the following SAS tools. The SAS Enterprise Guide was used to write the underlying SAS code, called as asynchronous web services. SAS Enterprise Miner was used to develop sample statistical models to be called by the asynchronous model scoring web service. And SAS XML Mapper was used to create an XML mapping file for parsing XML-based responses from the web services. In addition to those SAS tools, we used PuTTY, a free open-source SSH client for connecting to the Linux-based SAS host machine, and WinSCP, a secure FTP client used to transfer files back and forth between the host SAS server and our laptops. The first web service that we will demonstrate is the Master BI web service. The Master web service will demonstrate asynchronous calls to 3 analytical ETL jobs for a group of claims, and a 4th asynchronous web service that scores the data assembled by those jobs using a user-specified scoring algorithm. Calls to this web service are made asynchronously. In other words, a request is made to this web service and a response is issued immediately. Meanwhile, in the background, the service spawns off additional asynchronous web services performing ETL and scoring jobs, and catalogs the results of those web service calls in ETL and scoring logs. Expanding this node in the Project Navigator and double-clicking on the request editor reveals the WSDL associated with the Master BI web service. The WSDL indicates that this particular web service expects to be passed 4 parameters. The first parameter, group, is used to tie claims in a driver file to groups that can be processed by the web service. During this demonstration, we will present 3 use cases. The first use case presents a group consisting of a single claim to be scored. The second use case presents a group consisting of a small batch of 200 claims to be scored. And the third use case presents a group consisting of a large batch of more than 1,000 claims to be. The second parameter, request ID, is a unique ID provided by the calling application and is used to track different executions of the web service. The third parameter, model, provides the name of the model used for scoring. For purposes of our demonstration today, this argument can take on one of 2 values, fraud or severity. The fourth parameter, model version, provides the version of the fraud model or the severity model to be executed. Clicking on the green arrow in the request editor submits the service to be processed. After the request is submitted, the response from the web service is written to the panel on the right side of the request editor. In this example, the response echoes back the request parameters as well as the status of the Master BI web service. The status in this case is processing, indicating that the web service is currently processing the request, versus a status of completed, which would indicate that the web service has finished processing. The second web service that we will be presenting, ETL Call Web Service, demonstrates one of 3 analytical ETL web services called by the master service. This web service simulates a call to an external vendor's data service, like Experian, that returns a stream of XML containing a set of credit-related attributes for a group of claims. The request for this web service is fairly basic. It consists of a stream of claim IDs structured in XML. In response, the web service returns an XML stream containing the claim IDs, a set of 4 simulated credit bureau attributes for those claims, as well as a date and timestamp for when the web service executed. Here's the claim ID. Here are the simulated attributes, and here is the date and timestamp. Again, this web service is being called from the Master BI web service, but we've broken it out into a standalone call for demonstrative purposes. The next web service that we will demonstrate is the ETL Log Interrogator. As previously discussed, the Master BI web service and the underlying child analytical ETL web services are executing asynchronously. An ETL log table stores the status of all requests made to those web services, including the job status, either processing or completed, the return codes from SAS indicating warning, and error levels, start and end times of the processes, and other diagnostic information for each of the ETL jobs associated with a given request ID. We've created this web service to interrogate the ETL log table to determine the status of the child process and return all relevant log information to the calling application. In this particular example, we're using request ID 3002. In response, we can see that there is an entry in the log table for the master ETL service, source name equals master, and separate entries for the 3 child analytical ETL jobs. SQL-based ETL job, web service-based ETL job, and a SAS data step-based ETL job. Note that all ETL jobs have completed. There's a status code equal to C, and they all have return codes of 0, indicating that there were no errors while processing. At this point, the scoring process should have begun executing. The fourth web service that we will demonstrate, Score Log Interrogator, queries the score log table for a given request ID and returns job status information for that scoring process to the calling application. After submitting this request for request ID 3002, we can see that the score process has completed. The status code is set to C, and the return code is set to 0, indicating that the scoring executed without error. At this point, we can see that the master web service and all child ETL services have completed executing, and we can move on to the fifth and final web service, which displays the results of the scoring process. The final web service that we will demonstrate provides both the inputs to and outputs from the scoring process for a user-supplied model, version, and request ID. This particular example displays the model variables used by the severity scoring model, version 001, for request ID 3002. Request ID 3002 corresponds to our first use case, scoring a group consisting of a single claim. As you can see in the panel on the right of the request editor, numerous variables were created by the analytical ETL service. Now that we have taken a fairly in-depth view into each of the web services for our single claim use case, I'll walk through the remaining use cases, a group consisting of 200 claims and a group consisting of more than 1,000 claims. For the second use case, we will submit the master BI web service for a different group, group 2, using a new request ID 3003 and for the first version of the fraud model. This group consists of a small batch of 200 claims. Once submitted, I will interrogate the ETL log to determine if the master and child services have completed. If the ETL services completed successfully, I will then interrogate the score log tables to determine if scoring is completed successfully. If so, I will then run the final web service that displays the inputs and outputs of the fraud model. So the first thing I'll do is run the master BI web service. Change the group ID to group 2, request ID to request 3003, and I'm going to change the model to the fraud model. Click on the green arrow to submit the request, and it echoes back my input parameters as well as the status of processing. Close this window, open up the request editor for the ETL Log Interrogator, change the request ID to 3003, and submit that web service request. I can see that the master has completed. Here's the master source name. The status code is set to C for completed, and the return code is 0. And the same will be hold true for the other child analytical ETL web services. At this point, I'll interrogate the score log for the same request. Change the request ID to 3003, submit that request, and confirm that it has completed with return code equal to 0. Finally, I will surface the scores associated with that request. Again, I'm using the fraud model, and it was request 3003. See that request is using different IDs and the variables are slightly different as well.
Thanks, John. Well, that wraps up our presentation on real-time analytics scoring. Check out our website, and in particular, our Tempo solution, for more information about real-time analytics scoring from Corios. Thanks again and have a great day.